Is Danny ready? All right, class. Wait, hold on. Wait. She's still chewing. I apologize. I just waited till you took a bite, and then I was like,
Okay.
okay, we ready?
Yeah.
Okay, so class.
Yes.
Thank you. All right. So I'm hoping you guys are actually getting caught up with a lot of the stuff. I'm going over it slow because it is complicated, and I have handed you guys the integral tables for your references. So hopefully that is going to help you actually with a lot of the stuff. So finding area under the graph of this function. Okay, so area under the graph means I'm going to take the integral of e to the x in terms of what variable? Okay, I'm going from -1, right? -1 to 1. But what variable am I actually doing?
To the x.
The x. So dx. So this is important because when we're actually doing this, you quite possibly could have a different variable in there, in which that all this e to the x could be referred to as a constant. You know when we did implicit differentiation, we had an x and we had a y? Do you guys remember that?
Yeah.
Okay, we had x's and y's, so quite possibly we could be taking the integral of the y instead of the x, where we would just treat that as if it is a constant because it does not have a y value. Make sense? Okay, so yes, we are going to, that is a possibility, but we're going from right there to there. Now, first, what is the derivative of e to the x?
To the x.
E to the x. So therefore, the antiderivative of e to the x is
E to the x.
e to the x, right? Okay, so this is going to turn into e to the x from -1 to 1. Upper bound is going to give me e to the 1. Lower bound, so it's minus my lower bound, which is e to the -1. So as I write this, it's e to the first minus 1 over e to the first. Because that negative exponent, put it down at the bottom. Super easy, right? Jenny, you got that? Okay, so interpreting the integral of a rate of change. Part 2 of the fundamental theory of calculus states that under certain conditions, if f, capital F, that means is an antiderivative. Remember, capital refers to, that is the integral of that, antiderivative of f, then, okay, as we plug this in, we get f of b minus f of a. Since f is an antiderivative of f, so f prime, so capital F prime, so that means I'm taking the derivative of the integral, which is just going to give me f. So again, right here, so this starts with the derivative, okay, the capital F with a little tick mark right there means that I'm going to have the derivative, so I'm taking the antiderivative of the derivative, which is just going to give me that again. So the notation is super important here. So if you see this right here with the capital F and the dash, that means it is the derivative of the integral. So it's the derivative of the integral. And so the integral of the derivative of the integral is just the integral.
I think you're using integral way too much.
Okay, so now capital F refers to integral, right?
Yeah.
This symbol right here refers to integral, right? Yeah, right? Okay, so this, the capital F, so with the tick mark, that means it's the derivative, right?
Prime.
The tick mark says it's the derivative, so it's the derivative of the integral.
Yeah.
But I'm going to take the integral of that, so the tick mark goes away. So the antiderivative, so I'm taking away the tick marks. That's what that says. So I'm taking away the tick marks. So this here undoes that right there.
Okay.
Does that make sense now?
Yeah.
Because the tick mark means derivative. This symbol is the integral. So they undo each other, so I get just capital F by itself. Is that a better way of saying it?
Yeah.
Okay. Morning. Okay, in other words, integral from A to B of the rate of change of F equals to the change of F from A to B. Population in the United States is growing at a rate of, okay, so again, this is going to be a rate of change. It's a rate of change because it is the derivative of the integral. So that's a rate of change. And we know rate of change refers to the
Slope.
very good slope. There we go. So it's a slope. So my equation is 2.867 times quantity of 1.009 raised to the t. So since this is a positive number right here inside this parentheses, that refers that it is an increasing population right there, and using this, so millions of people per year, where t is the number of years since 2015. So since 2015, so that means that the 0 on the bottom is referring to 2015, and then the 5 would be 5 years later, which refers to
The interval?
2020.
Oh, okay.
Because if the 0 is my start at 2015, 5 years later is going to refer to as 2020. But we'll talk about that here in a moment as part B. So what this says is I'm going to take the integral of the slope on this one. So that means that's going to give me the function. So now I have to go and take a look at this. And off to the side right here, it's actually on one of your things, but I will write it down for you. So the integral of a to t dt is equal to, that is a to the t ln a. Let me double check. Yeah, ln a. There you go. So this is going to be helpful for a lot of this stuff. It is in your reference sheet. So if you go and find, it is on that same one. What did I say? It's page 6?
Page,
No, yeah, page 10. Page 10. Exponential, page 9. I know it's in here because I actually saw this. Oh, it's actually on page 6.
okay.
So it's number 5 on page 6. It's a to the u du. So we get that. All right, so given that, so 2 point, integral from 0 to 5, 2.867 1.009 raised to the t dt. Did I write that down correctly? I hope so. Okay, good. So now, in this one right here, this is going to be referred to as a constant. This is a constant. It's a constant multiple. So it's just multiplying what I have as my variable or my exponent. So that is just going to be referred to as a constant for this. So as I take the derivative, this is going to be referred to as my a in my formula that I showed you, which is a to the t. Okay, so that's going to be the a, and there's my t right there. So this out here is going to go 2.867. So I'm going to factor out a constant multiple. Anytime I have a constant, I'm going to factor it out of my answer. And it's going to make my life easier so I don't have to mess with that one. And now we could actually do this part here. We could do this part right here. So if this was my A, right, and that's the T, my answer is going to be 1.009 T over ln 1.009 from 0 to 5. That makes sense, or is that a whole lot of nonsense? If I'm not making sense, you need to speak up now.
The LM. Why? Oh, that whole equation.
Yeah, this right here. So the integral of a to the t dt is a to the t over ln a.
That was number 5.
Yes, that is number 5 on page 6.
Okay.
So now we could actually do the math on this one. So now this is going to give me 2.867 1.009 raised to the 5th over 1.009 minus 1.009 to the 0 over 1 ln. It's supposed to be ln down here. I messed that one up. ln and since I don't know these things off the top of my head, and I don't expect anyone to ever in all of Mathematica, so I'm going to put all the handy dandy calculator. So we have, so let's start off with the outside. So 2.867 parentheses, and then I have control divide. So if you guys are actually putting in the calculator, but some people, here, put it here so you guys could see it. Okay, so I said it is 2.867 parentheses control divide 1.009 raised to the 5 over ln of 1.009 close, move over, and that is minus the top part, control divide, which is my 1 point raised to the 0 over ln of 1.009. Ah, dang it. Are you no worky? There we go. Ah. Like that. So when you're going back home looking at this, so we're going to get an answer of 14.661. Now, in the problem itself, interpret it what it means. So it says where t is the number of years since 2015, so that's why I'm dealing the dt here in terms of time, that 0 is 2015, and then a 5 would be 5 years later past that, which is 2020. So, in the context of the problem, what are we actually referring to in the problem in the first place? We're talking about population. So, in this case, the population grew from 2015 to 2020 14.661 million, because this is number of years in millions of people. There you go. That's the interpretation. If the population of the United States was 320 million in 2015, what is the projected population in 2020? So what am I going to do? I'm just going to add it because it is increasing. So 320 plus my 14.661 is going to give me 334.661 million. Is it true? I don't know. But that was according to this time frame. This one we were projecting the population in 2020.
U.S. population 2015 was 320 million.
Mm-hmm. That's a U.S. Census Bureau. But what about 2020?
Projected growth was actually 332.
332?
329.5 million.
329?
Yeah.
Okay. So was this a overestimation? Yeah, it was an overestimation on that one. All right. That being said, let's take a look. Do we have the next one? No. We're doing this one tomorrow. So.
334 million is actually 2023.
Oh, okay. Off by a couple years.
Yeah, off by like 3 years.
Okay. So we're gonna do number 7 tomorrow. So you guys work on your assignment. Hopefully you guys get as much done as you can. If you're already